welcome to today's lesson of Arduino microcontrollers. Today we're going to start learning about serial communication. Now, serial communication is how we can use our Arduino to talk to a computer so we can monitor different values. But on top of that, we can also use the serial monitor function to write different actions for our Arduino to perform. So in this lesson, we're going to be using a photoresistor to learn how to play with the sensors and look at those values. But then we're going to move on into the next lesson, which is using the DHT11 sensor. You have that in your box, and the DHT11 sensor is going to be a humidity/temperature controller. So we can do some cool things with that. But first we need to learn core foundational skills of serial monitor. Right, so you should have a new sketch open at this point. We are using the create.arduino.cc editor. So now that we have that, I'm just going to go ahead and type in this comment, serial communication. I'm going to call this lesson 1 for myself. You can name this whatever you want, but I think this is a good way for us to know what we're working with. Okay, let's go on line 4. Hit enter a few times just so we can create some space for us to work with. And we are using that photoresistor. Now, that photoresistor is kind of cool. It actually we can control basically an LED or other sensors if we want to perform certain actions if the photoresistor is reading light on it or if it's reading dark on it. Kind of think of like a, maybe like a solar light if you have those outside at your house. Where once it gets dark, it turns on the light. We can essentially do the same thing here. So the thing we need to do first is set up a constant integer, so constant integer. We're going to call this one just sensor. Constant integer sensor is 0, of course. And we are this is going to be our input pin. We're actually going to be going with 0 for the input pin. A little different than what we've used in the past. Next, we need the integer val is 0. Semicolon, and we're good there. Let's jump into our void setup, and in our void setup we're going to use our first way of actually using serial communication, and that is opening up the port on our computer basically, or on the Arduino I should say. So we're setting it to serial.begin. So serial.begin is how we set up serial monitoring on the Arduino. And we're going to be putting what's called a baud rate of 9600, or 9600 bits per second is what it actually means. Once we have our serial begin set up at 9600, we can jump into our void loop. And in our void loop, we're going to do val equals an analog read of sensor. Okay? So again, value, which we have set, or val, which is set to 0, we're then saying val is going to be changed, the integer is going to be changed based off of whatever sensor is reading using our command analog read. Now, analog read is the opposite of analog write. Analog write allows us to set anything from 0 to 255 and push that power out. Analog read is actually reading all of those values from 0 to 255. In this case, whatever our sensor is displaying. Okay? Then, for us to essentially make our Arduino write out this information so we can see what that sensor is actually saying, we can use the command serial.print line. We're printing the line of val. Okay, and we'll write a delay in there, a delay of 100 milliseconds. And that's all this is for this program, but what's going to happen is we connect the photoresistor. Photoresistor is seeing, how much light is hitting off of that. The Arduino's reading that and assigning the value accordingly. If there's a lot of light, so full brightness on it is 255, complete darkness is 0, and anywhere in between, is essentially shade, right? So it's reading that, and then it's going into our serial command, and it's printing the line of that value. So print ln stands for print line, and then we want it to print the line of the value. Now we can have some fun with this if we wanted to. So now that we have this, we kind of understand what's going, but just to understand how serial communication works as well, we can do new sketch. All right, and I'm just going to show you how this can work for other things. So we could actually send secret messages if we wanted to with our Arduino, where people could plug it in and it reads it. So we can do serial.begin. We're going to set that baud rate of 9600. Okay, and in here we can do the serial.println. Oops, sorry. And don't capitalize that. This is going to give us some good things to talk about as well. Serial println, and then maybe I want to call it hello world. Right? So basically what we're doing is we're just telling the Arduino, in this case for the serial communication, of set the baud rate to 9600, and we can set that to different baud rates as well. 9600 is usually just a standard. Then our void loop, and it's printing the line. In this case, if I want to ever write out full text, this is just in general for coding stuff, you always put it in between quotation marks. So print line, hello world. And then what it would do is it would print the line, hello world. Now, if I don't want to over spam the serial monitor, I can do a delay command. And you should always put in a delay command, really, because that's going to help the serial monitor just not get bombarded, and you're going to get like infinite amount of stuff. It's going to tell it to take its time. So maybe I want to do every, I don't know, 700 milliseconds, it'll print the line, hello world. Okay, that's how that's working. Now some things, I'm going to jump back over onto this one here. We can talk about a common issues again with this. It's going to be if we don't have our constant integer set, semicolons, serial.begin. So unlike other things that we do where, you know, we have lowercase and then a capital in there, right? Serial commands require the serial to be S and serial to be capitalized, and then everything else is lowercase. Something to keep in mind, semicolons. Your delay command, that can always be an issue. Really, stuff like this, you're just making sure you have semicolons. We could verify this right now. Hooray! So we know that this is indeed working, or would be working when we get it hooked up.